All right, guys, so last time we said that temperature is proportional to kinetic energy, and then we drew kind of one of these plots where we have kind of number of molecules, or sometimes you'll see fraction of molecules, and then here you'll see velocity, and the plot looks like something like this. So at one temperature, most molecules are moving this speed, some are moving slower, and some are moving faster. And remember, kinetic energy was equal to mass times velocity squared. So let's take a look at what happens when we get hotter or colder. So let's go ahead and just say that this plot is kind of, oh, that's really bad. Let's go with this is kind of warm. Let's see what happens when we get hotter. So if we're thinking about the average, it's kind of somewhere over here. And so if we get hotter, our velocity, our average has to increase. And so that's going to happen. The other thing that's going to happen is what you'll see is that the curve starts getting kind of flatter. So it kind of looks something more like this. So this will then be hot, right? And then your average temperature is somewhere over here. And then if you went the other way, it would be cold. It'd kind of be less flat. So something like that. You can see the average temperature or average velocity here has decreased. So if you're shown kind of one of these plots with these kind of three lines through it, be able to identify which one's hotter, which one's colder. And so this picture kind of shows the same thing. You can see here we're kind of cold. Here we're hot. You can see cold, we're less kind of flat, we're more kind of poking up, and then you can see the average is obviously at a lower kind of speed. So as you get hotter, the curve flattens out. So temperature is proportional to kinetic energy. Kinetic energy is equal to mass as well. So let's take a look at what happens when you have stuff at the same temperature. What do the velocities look like? All right, so we'll call one of these A, and then we'll call one of them B. And we'll say A and B are at the same temp. They're at the same temperature. If they're at the same temperature, they have to have the same kinetic energy. All right, and so I'll tell you one of them is helium, and then one of them is xenon. So go ahead, pause the video, and think about which one is which for a second. So if we think about same kinetic energy, again, it's that kind of question. In order for a truck and a motorcycle to have the same kinetic energy, the motorcycle must be moving much faster. So if you have the same kinetic energy, but different masses, the light thing must be moving much, much faster than the heavy thing. And so which one is moving faster? Well, if you think about where the average is, it's B. B is moving faster. So B here is going to be helium, while A is equal to xenon, right? And so again, you can think about what happens if in order for two things to have the same kinetic energy, if they weigh different masses, the lighter thing must be moving faster. So just be able to identify these two kind of plots, identify, which one's hot, which one's cold. And then if I ask you, one gas is heavy, one gas is light, be able to identify which is which.